All right, hey guys, so we are going to do, let's see, 1, 2, 3, 4 problems, or it's really 3 problems, one with 2 parts, for your arc length independent practice today. These are, you're going to solve for the arc length exactly the same way as you've been solving it in week 4, where we did the practice notes worksheet, and then you did your quizzes on finding arc length. So some of these questions may be a little bit different or a little bit harder. 2 and 3 just give you different pieces, so you have to do a little bit extra work, but we're going to go ahead and get started. All right, so for number 1, part A and part B both use the same circle. All right, so for part A, it says if XH is 10 feet, so X to H, if this is 10 feet, which means the radius, if the radius is 10 feet, and the measure of arc XY, so the measure of arc XY is 100 degrees. Now, this is not arc length. This is your arc measure because of that little M right there, which means that arc measure is exactly the same thing as central arc. So if you want to put 100 there instead, you're more than welcome to do that. I know it's kind of hard to read, but you're saying that this central angle right here is 100 degrees, and you're saying that your radius is 10 feet. All right, so it says then determine the arc length of X to Y. So we want this actual measure. How many feet would that be? All right, so we're going to use the same exact proportion that we've been using for arc length. So the bigger the central angle, the bigger the arc length. Okay, so the first part we start with is the central angle over 360. So you know this is part of the angle over 360 is the whole angle, equals part of the arc. So this will be the arc length out of the whole arc, which is the whole distance around, which is circumference. Okay, today for circumference, we're going to use 2 times the radius times pi, or 2 pi r, just because every problem we have today gives us radius. If you wanted to use the diameter, then it would be the diameter times pi, because 2 radius put together is the diameter. So we are going to use this, this formula for circumference today. All right, so that's what we're going to do. So we're going to come over here for part A, and we're going to set up our, we're going to go ahead and we're going to set up our proportion. So our central angle is 100 degrees out of 360 degrees equals, we don't know our arc length, we're solving for our arc length, over our circumference. So our circumference is going to be 2 times the radius, which is 10, times pi, which on here, it doesn't give you that direction, but make sure you're using 3.14 for pi. Okay, so to solve a proportion, you're going to cross multiply. That means we're going to multiply x times 360, so that's 360x. And then we're going to multiply all of these values together. So 100 times, 100 times 2 times 10 times 3.14, and you get 6,280. Then to solve this equation, we're going to divide both sides by 360 to get the x, or the arc length, by itself. So divide that by 360, and you get this really long decimal. So on these today, it's not in the directions. It is going to be on your next assignment. So the directions are how to round. We're going to round to the nearest tenths place. So to do that, x is about, we're going to use 17.4. And to estimate to this tenths place, we have to look behind it. So we're going to use the 4 behind it. All right, so we want to round to the tenths place. So we look behind it. That 4 is not big enough to round that up. So we're going to say that the arc length is about 17.4 feet. Okay, and if this length is 10, you know this one is, it's going to be a little bit bigger, and 17.4 makes sense. Okay, so now we're going to go for part B and use the same circle. So what I'm first going to do is I'm going to erase all of these values it gives us, because I'm not sure what the question's asking. It may be different. Okay, So part B, if yx equals 24, if our yx equals 24, there's no little m there, so we're not talking about measure. So we're saying that this arc from y to x is actually 24 meters. That's the length. So this may be the first problem we've done where it actually gives you the arc length, okay? And it says the measure from y to x. So this arc measure is 120 degrees. So that means that this arc right here, or this central angle, because we know that they're the same, is 120 degrees. It says then determine the radius. So we haven't solved for radius yet. However, if you look at your proportion up here, the only place that the radius is necessary is in the circumference. So when it says determine the radius, I'm going to kind of give you guys a little note over here. So I want you to find the circumference and then find the radius. Okay, so that's going to be how we do this. You're going to find the circumference first, and then we're going to find the radius once we know the circumference, okay? So you're going to set up everything just like you did before. So we know our angle is 120 degrees out of 360 degrees, okay? This time, we know the arc length is 24, but what we're solving for is the circumference. So you're going to put an X for the circumference. Okay, so then same thing, you're going to cross multiply 24 times 360, 120 times x. So you get 120x, and sometimes I flip the sides, it doesn't matter, equals 360 times 24. You get 8,000. Ooh, you really can't read that, can you? There you go. 8,640. And then we're going to divide that by 120. Nope. 8,640 divided by 120 is 72. So you have x equals 72. Now, the only thing that you have to remember here is that this x, this is the circumference. So you have to be careful. That is not the answer. Okay? So now, the only extra step you have here is we know circumference is equal to 2 times the radius times pi. If you know the circumference is 72, you can plug that in. You know 2. We're solving for the radius, and you know pi is 3.14. Okay? Then what I like to do is multiply these two numbers together, so I kind of start getting all of my like terms together. So you have 72 equals 2 times 3.14, that's 6.28, times r. Bring down your r. Now all you have to do is solve for r, so you divide both sides by 6.28. Those cancel. I'm going to switch sides here. So r is about, let's see what we get, 72 divided by 6.28 is this really long number, okay? So what we're going to do is we're going to round to the tenths place, so we're going to use 11.46 to start. So 11.46, we want to round to the tenths place, so we're going to look behind that to the 6, okay? That 6 is bigger than 5 or bigger, so that means this 4 is going to round up, so your radius is about 11.5. And if you want to use your meters, that would be the right unit. So it's 11.5 meters. Okay, so if we go back and look, if this whole arc is 24 meters, that means that your radius should be less, and 11.5 is less. Okay, so our answer at least makes sense. All right, so now we're going to go down to number 2 and number 3. Number 2 and 3, they use the same exact circle, but they have different measurements. So I went ahead and gave you the circle twice. All right, so these two, you just really have to pay attention to the information they give you. They're actually, this one, number 2 is actually really easy, but you have to pay attention to what it says. All right, so it says if G to A is 12 feet. So G to A is 12 feet, so they're giving us the radius. And the major arc, GDR, is 200 degrees. So the measure of the major arc, so G to D to R. So G all the way around to D to R. So we're talking about this angle right here is 200 degrees, which makes sense because it's a majority of the circle. And here, this maybe talking about this big part right there. Okay, it says then determine the minor arc length of GR. So this part is the important part. You are solving for this length from G to R. So this length is not going to be the arc length for the 200 degrees. That would be G to D to R. That would be your major arc. They're asking for the minor arc. So what we have to do is we have to figure out what this angle is. Because if you solve for 200, then you're going to get this large portion of the circle. We only want this little part of the circle. So to do that, you know the whole circle is 360. If you take away the 200 degrees, you're left with 160 degrees. So we know that the little piece of this circle is the central angle is 160 degrees. Now that you have that, you can solve for your arc length, and you're going to do it the same way. So 160 degrees out of 360 degrees equals x. We don't know the arc length over the circumference, which would be 2 times the radius, which is 12, times pi, which is 3.14. You're going to multiply. You're going to cross multiply. So you get 360x equals 160 times 2 times 12 times 3.14 is 12,057.6. Okay, then you're going to divide both sides by 360. Sorry if you can't see that. You're going to have x is about, I'm assuming this is not a perfect number, divided by 360 is about this number. All right, so what you're going to do, we're going to round to the tenths. I know it doesn't say it, but I'm telling you now. So 33.49, if we're rounding to the 4, then we have to use the number behind it. So it's going to be 33.49. If we're rounding to the tenths, we have to look behind it. That 9 is going to tell 4 to go up 1. So the actual answer is about 33.5. And if you want to use the correct units, it's feet. Okay, so think about this. If this is 12, now this really isn't drawn to size because I don't really agree that if this is 12, then this is 33.5 feet. However, it is correct. Unfortunately, some of these circles aren't drawn to size. All right, so that one was pretty easy, pretty straightforward. The only thing is they gave you this arc, so make sure you're not using this arc measure or this angle measure. You're using the one that coincides or corresponds with the arc length they're trying to find. All right, so number 3 is similar in it gives you different pieces of the circle, but this time we're solving for the radius, okay? So anytime you're solving for the radius and arc length, and they give you arc length, then you're already thinking we're going to need to solve for the circumference. Okay, so it says consider the circle with center A, the minor arc G to U. So the minor arc, so G to U, this measure right here, is 24 units. That means the actual measure. It's not 24 degrees. That is, if we straighten that out and measure it, it's the actual length, okay? And the major arc G to D to U, so all the way around on the other side, G all the way to D, all the way around to U. This measure right here is 270 degrees. So you can say that the arc measure is 270 degrees, or you can say the central angle is 270 degrees. They're exactly the same thing. And this makes sense because it's the majority of the circle. Then determine the radius of circle A. Okay, so the first thing that I would do, we're going to do this 2 different ways. I'm going to solve for this piece of the circle so I know how many degrees goes with my actual arc length that it gave us. So if we have 360 minus 270 is 90. And if you think back to your rotation, 90, 180, 270, then you should know that should be pretty easy for you. If not, just subtract. Okay, so first way we're going to do this is the exact same way as we did before. If we know the arc measure, if we know the arc length, then we can find the entire circumference, and that can help us find the radius. So the first thing we're going to do is set up our equation. So 90, proportion, over 90 degrees over 360 degrees equals 24. That's part of the arc, and we're going to solve for the whole thing, x. So we're going to solve for circumference first. Okay, so we are going to cross multiply. So 90 times x is 90x equals 360 times 24 is 8,640. Divide both sides by 90. This is actually divisible by 90. And you get 96. So this is saying the circumference of the whole entire circle is 96 units, okay? So what we would do is we would then solve for circumference. So circumference is 2 times the radius times pi. If we know our circumference is 96, we can fill it in. Equals 2 times the radius times 3.14. You can divide by 3.14 and then divide by 2 on both sides separately, but I think it's a little easier if you just combine these. So 2 times 3.14 is 6.28. Bring down your r. And then you just divide on both sides to solve for your r. So 96 divided by 6.28. You get something that is not perfectly divisible. So we're going to round. So we're going to have the radius is about, we're going to round to the nearest tenths. So we have 15.28. We're going to take that, 15.28. We're going to round to the tenths place. So we're going to look behind it. That 8 is going to make that 2 round up to a 3. So the radius is about 15.3 units. Now, you know that the radius has to be less than the circumference, okay? So you know that that should be much smaller. All right, so this is way one. This is one way to do it. It will work every single time. Because this circle is separated into 90, then there is another way that you can think about this. There's an easier way to solve for the circumference. So we can kind of think about it like this. If you know that 90 degrees has an arc an arc length of 24, if you break them up into 90s, that means this section would also be 24. The length here, this length would be 24, and this length would be 24. So that will give you your entire circumference. So the circumference would be 24 times 4, which is 96. And that is exactly the same circumference you got here. So that may be a little easier. And then you're going to do the same thing. Circumference equals 2 times the radius times pi. Fill in your circumference. 96 equals 2 times the radius times pi. Divide by 2 pi. We're really doing the same exact thing we did on the other side. So this is really 2 times 3.14. So 96 divided by 6.28. You get the same thing. Your radius is about 15 that 8 rounds that 2 up to a 3. So this way is probably a lot easier for some of you. However, it's not always your central angle measure isn't always a multiple of 360 degrees. So it's not necessarily always possible to do it this way. This way, solving for your circumference, filling in your circumference and solving for r, this will always work. All right, so this extra step where you have to solve for the radius, there's just an extra step to it. The reason that we solve for the circumference is because out of this entire proportion, everything that we're doing to solve for arc length, the only part that the radius is needed for is the circumference. And so out of this whole proportion, that's going to allow us to solve for r. So we're going to solve for this part first, get this circumference, and then use it to find the radius. All right, so remember, this is your arc length. This is your independent practice. This week, we're doing things a little bit differently. If you watch my video kind of explaining everything that you click on, I thought it was a little confusing last week where I gave you some problems on a worksheet that we did together. Then I made you go fill in some on the internet. So instead, I just separated it into 2 different assignments. So it's going to look like you have more assignments, but it's the same amount of work. So we did these 3 or 4 problems together. You're now going to click the link on the next assignment, and it's going to say arc length extra practice problems. And so it's going to be the extra 3 or 4 problems from your independent practice that I would like you to do on your own. So I thought that would be a little bit easier. If you have any questions, please let me know. The only way that I know that you're not getting it is when you plug those answers in and you're getting them wrong. And then I've reached out to a few people. Some of it, you're just inputting it wrong into the computer. Others needed a little bit of extra help. So I need to know that. You can message me on Remind. If you're not on my Remind, please, if you have a cell phone, do that. I send out messages. It's the easiest thing in the world. Kids snap a picture of a problem to me and I answer it super fast. You can always email me. If you use Teams, I answer my Teams messages. So if there's literally any question that you have, please let me know. Otherwise, I hope you're all doing well. I hope you're understanding it. We're going to do a little bit, add a little bit to our area and circumference from the last 2 weeks. So if you have any questions, please let me know. Have a good day.